So what we are going to do, I am going to walk you through how to very quickly set up this deck with Nebius, and you'll probably be surprised how quick that is. So you can, in 10 minutes, get started with this deck and Nebius, and then I'll show you a couple of examples, such as dev environment and then distributed training. So here we go. And we start by, of course, installing this deck. The easiest way to do it is through UV or pip. It's a Python package. There is also, of course, like things like Docker image and everything, but the easiest is to start with UV. We've just installed the UV dstack CLI, and then we are going to configure Nebius. This is how it's done through the config file. We can have multiple projects. For now, we're just creating one. And because we are here talking about multi-cloud, I'm just giving you an example how you would combine. For example, if you are using hyperscaler and then you'd like to use Nebius next to it, you configure both and you just pass it the credentials, which can be the default or explicit ones. It's very easy to generate these credentials for Nebius. It's just one CLI command. And once you are good, you can proceed and start the dstack server, which is done by the dstack server command. And it starts the control plane. You can start it on your laptop, or you can deploy it to your Kubernetes, or you can deploy it anywhere. Once you deploy that, it's a single source of truth for all the workloads which you are running across multiple clouds. It stores logs, it stores the state, and it also provides multi-user experience where each user has the individual user token that they can use to interact with the platform. And this is what we are going to do here. So here's the URL to the control plane. You don't have to use the control plane all the time. You're mostly using the CLI. You can do many things through this control plane. As you've seen, we are using our admin token here to log in. And just to show you that this deck is actually connected to the clouds, we click offers and we see all the offers available through all the providers here, which is AWS, GCP, and then Nebius. And here we can just see the only Nebius offerings that are available on demand. So we see all the GPUs that are now available within our account, which we've configured. So now the server is up. So what we are going to do is I've prepared some project with a few configurations, which I'll walk you through. And the first thing we will do, we'll create a fleet. This is important to note that this tag is always declarative and it's CLI first. And so whatever you do, it should be explicit. So for example, if you'd like to use compute through particular cloud providers, first you create a fleet. Fleet is a template for creating node groups or instance groups, which can be clusters or something else. You can specify what GPUs are allowed, how many instances are allowed to be created. And then once you create that fleet, now anyone on your project can use that fleet. And this tech is able to provision this compute automatically, elastically as you need through that template, which we call fleet. Maybe to mention here idle duration, right? Because this fleet is elastic, it means that compute can be created on demand if you really want, or you can of course pre-create it in advance. But if it's elastic, you can also specify idle duration. It's for how long an instance can stay idle before this deck would kill it, which is also sometimes great because you run multiple things with some little pause between them and you don't want to reprovision that. So it just gives you fine control over there. So now the fleet configuration is ready. We do this tech apply, just like I mentioned in the slides here, and we pass the configuration. We just say yes. And as you see, fleet is created immediately and we don't see any instances because we've set this fleet to be elastic, because instances will be provisioned as we run something. And this is what we are going to do now. So as a very quick one, by the way, this is the command that shows all their fleet instances. -w means it's to watch it, to watch in real time what instances are there. So for you to understand what's going on. And now we are going to start to run a very simple thing, which is the dev environment, as I mentioned it in a slide. This is the configuration of a dev environment. Basically, we don't specify much. Here, it's only Python version, and then we also point it to a particular fleet if we want. Otherwise, this tag would pick it automatically, and then we say just which ID we want to use. But there's a ton of things that you configure there. And now we use the dstack apply, pass the configuration file. It will of course, check the fleet which we've specified, and it will prompt us to confirm the plan. It also shows which instances match this template. And now as we confirm, it will automatically run the instance. It will pull the Docker image and will start this ID server on the instance. So when we access it, it's already pre-warmed and we can just use it right away. And on the right-hand side, you can see also that there's now a new instance in the fleet. As you see, all is configured, and we just copy that URL URL, and we can use it either through desktop ID or we just open it in the browser. And once we do that, we see that our desktop ID, which is Cursor here, it must be Cursor 2.0, by the way, which was just released. But we see that we are on that remote machine. If it has GPUs, we are able to access it. We can use all our plugins, we can use our Docker image and repo, so it's pretty convenient to use. And as an ML engineer, you don't really need to think of all the infra at all. That was a very simple one. So what we're going to do now is we are going to create a cluster fleet, which we say it's an interconnected cluster with 2 nodes. And we also specify GPUs. Each node has H100, 8 GPUs here. And now we use dstack apply, where again, we pass the configuration. It detected that with the Nebius, we have these instances supported, these GPUs, and we confirm, and now dstack would provision this cluster. And on the right-hand side, you see the process. And we see now that one instance is idle, another is provisioning, and now both instances are idle, means that we now can use this cluster. And before we use that, we will check how cluster is performing. As you see idle on the right-hand side, it not only means that nothing is running, but it also means that dstack checked the GPU health and is sure that if you run something there, it will run properly. Otherwise, if there's any DCGM failure or warning, you would see that in that CLI. But again, it's not always about individual GPU failure, but it's also about the GPU interconnect. And sometimes not, in most cases, when we talk about cluster, it's not about GPU interconnect, but cluster interconnect, because when we do a complex training or inference, all the GPUs have to talk to each other. And the easiest way to, for example, test the network, to do the test, is by running NCCL tests, because NCCL is something that you don't really have to know it like upfront. You'll learn it as you go, but this is what really makes this training or inference efficient under the hood inside the PyTorch. And here we're just going to use a task. We are going to run MPI run. It's just a way to run something on a cluster, and we will just run this NCCL test. So this is a task definition. We just say, okay, so if this is a master node, run MPI and pass the list of their nodes inside the cluster. And if it's not a master node, just sleep in infinitely until dstack will kill you. And we also specify, of course, resources and some other properties, but because we are pointing it to a particular fleet, dstack will just figure this out automatically. Again, we run this configuration and it detects this cluster here, and now it runs this on all nodes. Just as with dev environments, with tasks as well, we're going to see real-time output of the master node, even though we can also attach CLI to non-master nodes as well, but by default it shows the output of the master node. We see that it successfully scheduled the run, and now we see the output of the MPI. It's a lot of output, it's a bit verbose, but what to pay attention to is that the keyword IB. IB means infinite band. The test will do a number of tests according to the default configuration, which will test the bandwidth between the GPUs. Here we have the final result, and again, this is average between different configurations. Main point here is that the cluster is absolutely functioning well. Here's a task that we're now going to use to demonstrate how training actually works. This is their task configuration where we just use torch run, and it's basically, as you see here, is the basic PyTorch distributed training example here. Yeah, we also use debug mode to have this verbose output to just ensure that we know what is happening there. We run the configuration. Now it will start the master node, and then once it's up, it will start all the other nodes. And this way, PyTorch will understand, okay, so we have a quorum, and now we can run the training. dstack will take care, again, everything like failure, recovery. If a node fails, then dstack would allow you to restart it according to the policy that you've configured with the task. And you, of course, are able to watch how it is performing. While doing so, of course, if you run it on Nebius, you can use in principle like MLflow or any other way to track there also some metrics of the training. So it just gives you a free choice of the tools. Here we go. So it was just a very short training just to show you how it works. And now we also, just to show you the control plane, that all the runs are there. all the jobs within each run are there. We can see the logs and output of each run, and also the metrics like CPU, memory, GPU utilization, which is pretty convenient to watch it as you run it. Same for NCCL tests. So it's multi-user environment, and it's an environment for ML engineers. You can connect it to the compute, such as Nebius, or also combine Nebius with hyperscalers, and then just bring your team and let them do what they want without them thinking of the infra under the hood.